is Mekshi Thakur. I will be presenting my research in progress on equity-aware explainable NLP for clinical decision support, specifically how we can audit and reduce algorithmic disparity in US healthcare. Moving on to our first slide here, which is the problem. So let me start with the code example. Imagine a hospital that deploys an AI model to predict 30 admission risk. On paper, the model looks good, an AUC of 0.82, which is considered good in healthcare AI. Leadership is happy, clinicians start using it, and everyone feels the investment was worth it. But when you break performance down by patient demographics, a very different pictures can emerge. That 8.82 overall might actually be 0.85 for white patient, but only 0.78 for African American patient and 0.76 for patient on Medicaid. That's a 7 to 9 point gap, non-trivial in clinical AI, and it means that the system is consistently less accurate for some of the vulnerable patients. These disparities are completely hidden if you are only looking at the aggregated metrics. This isn't hypothetical. Studies using dataset like Mimic 3 have shown exactly these kind of gaps across race, insurance status, and geography, with measurable difference in AUC, sensitivity, and calibration. Metrics that directly affect patients. Now, where does this explainable AI fit in? So tools like SHAP, Lime do a great job of showing why a model made a specific prediction. They highlight the influential system, lab values, or clinical note phases. So the problem that I'm addressing here is we need explainable AI that doesn't just explain, it must actively surface and help us address equity issues. Moving on to why this matters. So this slide shows why this is an urgent problem to address now, both practical and theoretical perspective. Practically, US healthcare is already marked by deep disparity across race, geography, insurance, and language. At the same time, we deploy AI widely for risk predictions, diagnosis, and treatment support. If these systems are biased and we don't monitor, we are not just automating decisions, we are automating inequity. So theoretically speaking, there is a disconnect. The AI fairness community builds sophisticated metrics like equalized odds and subgroup calibration. We have a fairness research optimization algorithm in isolation and XAI research building dashboard without equity as a core design goal. So we still lack equity first XAI framework that combines subgroup auditing, fairness metrics, and human in loop process in one cohesive system across the full AI lifecycle, which integration is exactly what my research targets here. Moving on to the foundation, which is this work builds on my prior seminar projects. So these are few seminar projects that I did in the past. Seminar 1, I used Clinical Bird and Sharp Lime to build explainable NLP models for CDSS, providing token level explanation clinical courses. In the second seminar, I used a design research approach to propose a conceptual framework for explainable NLP. And in seminar 3, I explored human in loop explainability, where clinicians don't just receive the explanation but also actively validate and refine models. The limitation of this prior work is that I focused on transparency and trust without targeting the disparity detection or equity. I never asked whether the performance and explanation were consistent across the patient group. So moving on to the key literature here, which is so to address the equity, I draw an AI fairness literature. So fairness is a multidimensional model. It groups the group fairness here means performance parity across demographic and groups. Individual fairness means similar patients should receive similar prediction. Intersectional fairness means patient hold overlap identities like Black, female, and on Medicaid that must be considered jointly. So what's missing in the transition layer to clinical practice is how do we turn fairness metrics into something clinicians and quality team can interpret and act on within the real workflow. Moving on to the equity framework for AI. So there is also important work which has already been done in the past based on equity by design framework. So there are few recommendations which was published in JAMIA 2024 AI CDS. So it outlines 12 principles which include lifestyle equity assessment, routine subgroup reporting, and governance structure. These frameworks point in the right direction conceptually, but also mostly they remain at the policy or the guideline level. They say what should happen, but not how to implement it in a working system. We still lack concrete artifacts that combines explainability, fairness metrics, and clinician feedback in one integration. Moving on to the research gap here. So all these studied leads to a research gap. Here I have made it in these three key tensions where my research addresses. So the first one is XAI without equity, which means explainable AI improves transparency and debugging, but it rarely audit performance or explanations across demographic subgroups. A model can be very explainable and still be very unfair. Second one here is the fairness without clinician, which means fairness metrics are optimized in technical papers, but clinicians are rarely involved in judging whether particular disparities are clinically meaningful or ethically unacceptable. We just need clinician judgment in the loop. And the third one is missing life cycle artifacts. So policy frameworks call for equity across AI life cycle, but it lacks practical tools that combine subgroup auditing, fairness metrics, and human in the loop review in a system. So my research gap is there's a limited work on equity awareness XAI framework that enable clinicians to see and understand the differences in AI CDS predictions and explanation across the life cycle. So moving on to the conceptual framework. So equity aware XAI architect is shown in this diagram here. So starting with the clinical data inputs, EHR text and structured data plus explicit subgroup attributes, these becomes equity audit dimensions. The second one here is the NLP model, which is a clinical BERT-based fine-tune for a task like 30-day readmission or in-hospital mortality. The third one here is the XAI layer. So this uses SHAP, attention map, and LIME provide tokens and feature level explanation for individual predictions. The fourth one here is the equity layer. So we compute subgroup fairness metrics, AUC, parity, equalized odds. For example, we can see whether the model weighs fever differently from different groups, if that makes sense. So equity dashboard is the next layer, and interactive dashboard, I think it can help visualize performance heat map side by side, a sharp plot, and allows drill down into intersectional subgroups like Black female Medicare patient. The last one is the human in the loop equity review. Clinicians and informatics review these disparities, distinguish expected variation from unjust disparities. Their feedback loops into the model and refinement and governance. So moving on to our key constraints. So subgroup fairness metrics is one of our key constraint here. So looking at the performance parity and calibrations. Equity dashboard is the next one, where visualization tool, where we can comparatively use SHAP distribution, performance heat maps, intersectional filters that makes disparity visible and explorable. The next one is the human in the loop review, structured review session where clinicians interpret and disparities, flag concerns, where we can assess perceived fairness and trust. Moving on to our research question here. So the first research question is the conceptual design. The first research question here is how did I? So the conceptual design, which is completed, this is like in my phase 1, and I synthesized the fairness, XAI, and health equity, and define the architecture and dashboard components. The second phase is the prototype development in progress. This one is currently in progress. And the third one is the evaluation planned, where this will start with expert evaluating cognitive walkthrough in this phase with formal clinician where users in the future work. So in the closing, I would like to say my work aims to move from transparent by potentially unfair AI metrics to equity awareness explainable AI, where clinicians can see and understand and act on algorithmic disparity. I'll take any questions that you have in the comments below. Thank you. Bye-bye. Hello everyone. Thank you so much for being here. My name is Mekshi Thakur.